Hello again and welcome to another video which relates to BenchEzy Advanced. In this tutorial we will be looking at the requirements that must be met when you are setting up your join bolt pattern templates within AlphaCam for use within BenchEzy. You can design and have as many different joiner bolt patterns as you like. You can also then within BenchEzy you decide which one of these you would like to use as your default pattern, but then on the fly as you're producing code for a benchtop you can actually select an alternate join bolt pattern for use in that particular benchtop that you're producing. What we're going to look at now is the particular requirements that must be met when you set up these extra join bolt pattern templates for your environment. Let's get started. What we'll be doing in this tutorial is just looking at the pre-installed join bolt pattern templates that are supplied with BenchEzy. As I've already said, you can design an unlimited number of joiner bolt pattern templates for yourself as long as they meet the requirements which we'll talk about here. Now as you can see, I've already opened a drawing here which is of the diamond joiner bolt pattern. Now any joiner bolt pattern must consist of only pure and simply 3 geometries. Now as you might remember, a geometry in AlphaCam language is in my environment just a green line. Now you can also drop down over here in your layers area. You can see that we have the geometry, we have constructions, we have toolpaths, dimensions. So when I click on each one of these geometries, you can see that the selected geometry highlights and turns into a different color. Now each join bolt pattern must have these 3 geometries. Now each geometry has a certain job to do. We'll look at the circle first. Now this circle must be a 10mm diameter circle. Now this circle actually is there to represent the center of the join bolt pattern when it is placed upon the benchtop. Now what BenchEzy does is it searches for this particular circle. It works out the center point of this circle, and that is the point that it uses as its reference to locate each and every joiner bolt into your benchtop. So it is important that that circle is located in relativity to the rest of the actual outer geometry of the joiner bolt pattern, that is placed in the center that you want to be the center in the joiner bolt pattern when it's placed into the benchtop. The first thing I'll talk about will be the outer geometry. Now this geometry is actually the geometry that will be used to actually cut the shape of the joiner bolt pattern. Now this geometry can be any shape you like, but it will represent the end finished product of your joiner bolt pattern in your benchtop when it's placed in there by BenchEzy. Again, as I said, you can design any particular shape that you want and use that then. And as I've already also said, that you can select a default template, but then on the fly as you're producing each and every benchtop you can select an alternate join bolt pattern for the particular benchtop that you're producing. The next geometry that we're going to look at here will be this particular line. Now in each join bolt pattern it is a requirement that you have one straight line such as this one here. Now what this line does, it tells BenchEzy the overall width of your join bolt pattern, so it can then use this length to calculate how wide each join bolt pattern is when it's calculating out how many joiner bolt patterns to put in to the length of a join. In this particular drawing it's actually located in the center of the diamond, which makes sense because that is the widest points of the particular join bolt pattern. The third geometry we will look at here is the circle. Now BenchEzy will look for a 10mm diameter circle within each join bolt pattern. Now what that circle tells BenchEzy is that it finds the circle. It then calculates the center of the circle. That point is then used as the reference point to locate your joiner bolt into your benchtop in relation to the distance from the face of the join, from the front edge of the benchtop, from the rear edge of the benchtop. So it is important that that circle is in each and every drawing, and it must be as a 10mm diameter circle. BenchEzy will check each template for you as it's throwing it into a benchtop to make sure that each template only consists of 3 geometries. If there's 2 or 4 or more geometries, BenchEzy will throw an error and say that your join bolt pattern is incorrect. You will not be able to proceed with that join bolt pattern until such time as the pattern is fixed to meet the BenchEzy requirements. So what we'll do next is we'll just slowly go through each of the join bolt patterns that is applied by default with BenchEzy and just compare how different they are and how each of these geometries is used in a different shaped pattern. Alright, so this time now I've opened up a circle. Now as you can see I only have pure and simply 3 geometries. Geometry 1 is the line, again, which tells BenchEzy the overall width of the geometry of the which it represents the joiner bolt pattern. We also have our outer shape of our bolt pattern, and then we have our 10mm circle again. This time we've got a keyhole shape type joiner bolt pattern. Again, you can see that we have our geometry, which represents the shape of the joiner bolt pattern. We have our line, which represents the overall width of the pattern. And again, we have our circle. Now, as you can see, this circle is not placed anywhere relative to the rest of the geometries. Now, again, remember that BenchEzy will find this circle. It will calculate the center point of this circle. That is then the distance that it uses to offset the joiner bolt from the face of the join, or from the rear of the bench or the front of the bench. Okay, again, another one of the default patterns that are supplied with BenchEzy. As you can see, this one has a triangular shape. Now, the other thing to remember as well with each of these patterns, that when these are put into a bench top, that the direction that these are placed is basically that, if you can imagine that the face of the join is towards the top of the joiner bolt pattern drawing. So again, we can see that we have our only three geometries: the line, which tells us the overall width of the joiner bolt pattern. We have our 10mm circle again, and then we have our geometry that represents the outside of the joiner bolt pattern shape. And the last bolt pattern that is applied with BenchEzy is this particular one. Now, as you can see, again, we have our geometry, or our line, which represents the maximum width of the pattern. We have our 10mm circle again to represent the center of the pattern, and of course we have the outside shape of the joiner bolt pattern. The big thing to remember is that you must have these joiner bolt patterns saved in the correct format with a maximum of the three geometries. You must have your line, which tells BenchEzy the overall width of the pattern, and you must have your 10mm circle to represent the center of your joiner bolt pattern. So now, looking at this particular pattern again, remembering that the face of our join is towards the top of this drawing. So what this means is that for this particular type shape, you would more than likely probably be using something like a rounded joiner bolt pattern, whereas if you were using something like the previous pattern, you would be using like a metal toggle or something like that. Now, what I've done here, I've just inserted one of the other joiner bolt patterns into here to demonstrate the differences. Now, again, don't forget that the face of the join is represented towards the top of the drawing. The actual center point of the circle in relation to where it's saved in AlphaCam is incidental, because once BenchEzy calculates where the center of this circle is, it will then calculate how much it has to move or shift the pattern each and every time it puts it into a benchtop join. Now, just to reiterate the last few points, that you must remember there must only be three geometries in any one of these patterns. So as you can see now, I have 6 geometries in the drawing, but bearing in mind that I have here 2 join bolt patterns just for this demonstration purpose. The other thing to remember is that the outer geometry, the one that represents the shape of the pattern, must be a closed geometry. Now, a closed geometry is indicated by a very, very simple process to check to make sure that it is actually a closed geometry, and the easiest way to do that is to do this. By clicking the delete button, what you can do is just highlight the geometry, and as you can see, that geometry is one continuous dashed line. Whereas if I go over here to this particular geometry here and highlight this line, you can see here that this geometry, this shape, is made up of now 4 different geometries which represent the outer shape. Now, in essence, what that does, you can also look over here, you can see now that our quantity of geometries is increased. Now, instead of just having 6 geometries previously, we now have 9 geometries, when we should in reality only have 6 geometries in this drawing, because I actually have 2 templates in this drawing. So if you end up with a situation where you have this sort of a scenario where you have all of your outer geometries are not one continuous line, what you can actually simply do is select the join button in AlphaCam, and then you can then select all of those outer geometries, highlight them till they turn blue, hit your escape button, and then if you go back now and select your delete button, you can see now that they are all one geometry. Big thing to remember, that must be one geometry, must be closed geometry. Otherwise, BenchEzy will throw up an error because there's basically too many geometries in the joiner bolt pattern. I hope you found this tutorial beneficial and was helpful for you. Make sure you check out the rest of our videos on our website or on YouTube by searching HUTTO PTY Ltd, all one word. There's plenty there to look at.